Let us take a problem on escalator. Okay, this video is provided to you by iedubook.com, which provides free video lectures to various school students, CA students and MBA students. Escalator problem, computing the time taken. In a moving up escalator, a man can walk down in 80 seconds. Now, an escalator is something like a staircase, okay, which keeps on moving up. So if you come and stand here, okay, let's say a person stands here, this will keep on moving up unless and until it takes you to the level above, right? So there could be two situations. One, a man may walk towards the escalator, towards the direction of the escalator, or he may walk against the direction of the escalator. There's something similar to the upstream and downstream movement of the boat. So what does the question tells us? In a moving up escalator, this escalator is, let's say for example, moving up, a man can walk down in 80 seconds, right? So the direction of escalator is this, but the man is walking down. He's coming from top to bottom, and it takes 80 seconds to do this, right? He can walk up the same moving escalator in 20 seconds. If he starts moving up, then he can do that in 20 seconds. Given the speed of the man is same in both the cases, find out the time the man will take to go up the escalator when it is not moving. So the question is that if this escalator were to be stationary, right, then what is the time that it will take for this man to walk up? So as I said, this is something similar to the downstream and the upstream movement that we saw earlier. The downstream movement being when both of them are moving in the same direction, the upstream movement being when both of them are in the opposite direction, right? So let us assume that the speed of man is equal to x steps per second, okay, and the speed of escalator be y steps per second. So then when he is going up, what is the speed? What is the downstream speed that is there? That is going to be equal to x steps plus y steps, and we are told it takes 20 seconds, right? So in 1 second he moves x steps, so in 20 seconds how much he will move? He will move 20x steps, okay, and here it will be 20y steps. So the downstream speed will be 20x plus 20y. I can just take the convenience of removing this word steps from here. Similarly, the upstream speed will be what? The upstream speed will be 80x minus 80y. 80 times the speed of the man per second, because it takes 80 seconds to come down. And I've taken the speed of the man as greater because if it is not, then he will never come down. And 80 as the speed of the escalator, right? But you know that the total distance covered in going up and coming down is equal. So in other words, this d is equal to u, or 20x plus 20y is equal to 80x minus 80y, right? Take this x to the other side, so you will get 60x is equal to 100y, 3, 5, right? Or x is equal to 5 upon 3y. Or maybe better still, we can write this as y is equal to 3 upon 5x, right? Now what do we need to find out? We need to find out the time the man will take to go up, to go the escalator when it is not moving. So the time that the man is going to take to go up the escalator when it is not moving is equal to the distance upon speed Now what is the distance? Distance, we can take either of them, 20x plus 20y. So we can write this as 20x plus 20y, or 20 into 3 upon 5x divided by x. Speed of the man is how much? X steps per second, right? So if you take x common here, you are left with 20 plus 60 upon 5 divided by x. X knocks off this. 5 times 20 is how much? 100 plus 60, 160 by 5, okay, or 32, right? So the time taken will be 32 seconds when the thing is stationary, right?